Chapter 8.3, Perimeter and Area. So now that we have established certain types of our polygons, we're now going to look at what types of measurements we can do with those polygons. So first, some definitions. The perimeter, which we will often refer to as a capital P, of a two-dimensional figure is the sum of the length of the sides of the figure. So here I have a rectangle. The perimeter around the rectangle is just the lengths of each side added together. Now notice I say sum here. So these lengths are added up, right? So if this is, if one side is 3 feet, another side is 2 feet, 3 feet, 2 feet, adding them all together we get 3 plus 2 plus 3 plus 2, which equals 10. But what's our unit? Our unit is feet, because each of these is feet, and I'm adding feet together, right? Feet is what's called a one-dimensional unit. Perimeter is always measured in one-dimensional units, whereas area is called a two-dimensional unit. So the area is the measure of the region within the boundaries of the figure. So it requires 2 dimensions in order to formulate it. The dimension going like left, right, and up, down. Together, multiplying this together, we get a 2-dimensional space. And so area uses 2-dimensional units like square feet, square yards, square meters, etc. So one way to sort of remember what you're working with, perimeter versus area, is to look at the dimensions of your units and to look at the type of equation you're using. So when you're looking for a perimeter, which we will get to actual equations for these things in a moment, but when you're looking for perimeter, you're always looking for something that adds things up. Whereas area, you'll end up multiplying two lengths together, because that's how we get a unit multiplied by unit. Feet times feet equals feet squared, whereas feet plus feet is just more feet. So here we have formulas for some of our basic polygons that we've learned. So the triangle, we get its perimeter by adding up each of its sides. Its area is 1/2 base times height. Now notice that the height is not actually necessarily one of the sides of the triangle. The height, also known as the amplitude, is the distance from the highest point down to the floor or the base of the triangle. So if we had a right triangle, that height would be one of the sides. But barring it being a right triangle, generally the height is not one of the sides, so don't get that confused. We just pick whatever the distance is up to the highest point. So 1/2 base times height. Now where does this come from? Well, if we take a step over to our rectangle, a rectangle's area is length times width. That's probably the one you're most familiar with. We get its area from, if our width is made up of a bunch of units, say our width is 1, 2, 3, 4, 5, 6, so 6 units wide, so let's call that feet here. And then our length could be, let's see, 1, 2, 3, 4, 5, 6, 7, let's say 7 feet long. Then how many squares did I just make here? How many foot-by-foot squares, or square feet, did I just make? Well, I made 6 times 7, which is, what is 6 times 7? 42, which is 42 square feet, or sometimes we can write that as feet squared, whichever way you want to write that. So that's length, that's formed by the length of 7 times the width of 6, but we could also just count out the squares. Now for the area of a triangle, it is just 1/2 of the length times width, essentially. if I was to create a right triangle here, well, then its area would be half of 6 times 7, right? Because it's half of the rectangle. Here, the area of this triangle is half of the rectangle I could form from it, where the height takes the place of the width, and the base takes the place of the length, but it's still just half of the area of the rectangle that would make. So that's why we want the height, not just one of the sides, because that's the height of the rectangle that you can make. Next we have the square, which is nice because all of the sides are the same. So they're all length s, so we say a is equal to s squared, where s is the side length of the square. It is s squared because it is s times s. It's the same thing as L times W, it's just now the side is one thing. So it's s times s, which is s squared. Because a square is square, right? Parallelogram basically works the same way as a rectangle, but we use the same sort of notation as we do for a triangle, where we have a base and a height. But if we were to extract this little piece, this triangle here, it would fit in right here, and look, we'd have a rectangle of height, the same as width, and base is length, right? So it's base times height is the area of the parallelogram, not side length. Once again, the height here is the distance from the top to the bottom, not the length of this side. But the perimeter, on the other hand, perimeter is always going to be all of the sides together. So we add up each side, which is where I'm getting 2b plus 2w, because there are 2 b's and 2 w's right here, right? So we just add up everything outside. Then the trapezoid, the area is 1/2 height times base 1 plus base 2, where base 1 is the top and base 2 is the bottom. This again is very related to sort of the relation. It's sort of like the rectangle, triangle thing, but it's more like an average. So here I have an isosceles trapezoid, but this works for any type of trapezoid, where essentially what this does, if I was to rewrite it, it would be b1 plus b2 over 2 times the height. So that, in other words, this part, now this is the exact same thing, I've just moved this to here, right? This is taking the average of the two bases. So I'm taking these two bases, base 1 and base 2, and finding the average between them, then multiplying by the height. So it ends up being a very similar width times length situation, but we have two different lengths, so we average the two of them to get the actual length that we're working with. Then, of course, our perimeter is, once again, add up everything outside. So the height has nothing to do with the perimeter because the height is not actually a side of this trapezoid, just like it wasn't a side of the parallelogram or the triangle. So once again, here we have the perimeter and area formulas all summed up. So as I said before, we want to think about the dimensions of these formulas. That's what's really going to help you remember which is which. Okay, so here is in writing what I was trying to kind of describe pictorially before. So perimeter formulas are one-dimensional. They use 1D units like feet or inches, and only involve addition of the sides. So if we look at everything here, we have the rectangle is perimeter equals 2L plus 2W, but really that's just because they match, right, the L's and the W's. So we get L plus W plus W. Like, that's what that means. So it's only adding. 4 S's is S plus S plus S plus S. So it's still just adding the sides of the square. 2b plus 2w is just like 2l plus 2w. Side 1 plus side 2 plus side 3. Side 1 plus side 2 plus base 1 plus base 2. All of these are just adding the sides. Whereas for the areas, notice every one of them has one dimension multiplied by another. Length times width. Side times side. Base times height. 1/2 base times height. 1/2 height times base 1 plus base 2, but again, if I was to distribute this in, this would be height base 1 plus height base 2 times 1/2, right, when we distribute. So it's still only multiplying one dimension by another, which gets us a two-dimensional measurement using 2D units like square feet or square inches. So we require multiplication of exactly 2 dimensions to get that. Once we get to the chapter on volume, we'll see that there are that we get 3-dimensional units once we multiply 3 dimensions together. Now, for example, if we want to apply some of these area formulas to and perimeter formulas to some verbal problems, we'll start with Rob wishes to replace the sod grass on a lacrosse field. 1 pallet of Bethel Farms sod costs $360 and covers 480 square feet. The area to be covered is a rectangle with a length of 360 feet and a width of 228 feet. We want to determine the area to be covered with sod, determine how many pallets of sod Rob needs to purchase, and then determine the total cost of the sod purchased. So we're going to start with the area to be covered. So we're talking about what type of shape here. Well, it says it's a rectangle. So we're going to underline that. We want a rectangle. So rectangle specifically of length 360 feet, width 228 feet. So we can label our rectangle in the following way. Our area formula for rectangles is the easiest one out of all of them. It's just length times width. So in this case, it's 228 times 360. What does our unit end up being? Well, it's 228 feet times 360 feet, so we end up with feet times feet, or feet squared. In this case, 82,080 feet squared for our area. Now, determine how many pallets of sod Rob needs to purchase. Well, 1 pallet costs $360 and covers 480 square feet. So we could think out a proportion to solve this, or we can just sort of think about it a little bit logically here. We know we have the area of 82,080 square feet, and we want to cover how many, we want to cover 480 square feet with a pallet. So if we take the total and pull out each pallet, we're kind of dividing it up into blocks of 480. So I said the word right there, right? We're dividing it up. So in this case, we get the area covered will be divided by the area of a single pallet. So that 82,000 will be divided by 480 to get our 171 pallets. But if we wanted to think about that proportionally, remember we can build a proportion of, 82,080 square feet for X pallets is equal to 1 pallet for 480 square feet. Then we can solve the proportion. So whichever way you like to think about this, we of course solve through our cross multiplication. So 480x equals 8280, and then we end up getting x equals 82,080 divided by 480, and so we're right back where we started. So if you want to write out the proportion, it absolutely can help in a situation like this. Paying attention to your units, that's the way to solve word problems, is think about the units. That's always going to be the most helpful first step in any word problem, is think, how can the units help me to guide me towards what I'm looking for? So in this case, either way is perfectly fine. If you can think out what you're really doing, that you're taking the area and you're dividing it up, that can help you too. Or you can set up the proportion, which is a little bit more of a rigorous way of solving this. Either way, we end up with 171 pallets. Now, our last step is determine the total cost of the sod purchase. So our cost is $360 per pallet. So once again, we could set up another proportion where we end up with, we know how many pallets we want, we know the price per pallet. So if we wanted to do a proportion, we could say 171 pallets is X dollars, which would be equal to 1 pallet over $360. So when we cross multiply, we'll end up getting X equals 171 times 360. And that will get us to our answer. We can also just, again, think about this a little bit logically. So we know 1 pallet is $360. 2 pallets would then be $720. 3 pallets would then be, $1,080? Is that right? I think so, yeah, $1,080, and so on. Now, how did I get that? Well, I just kept adding 360, or I multiply the number of pallets times 360. Well, the number of pallets is 171. We can get the number of pallets by number of pallets times price per pallet, which is 171 times 360, which is $61,560. So whichever way of solving this you like, whether you like to set up the proportion or you like to think out what's really happening, either way will get you to the same result. Now the next equation we're going to look at is the Pythagorean theorem. So the Pythagorean theorem is a relationship that exists between the side lengths of specifically right triangles. Not all triangles, but only right triangles. There is a version of this for non-right triangles, but it is not something that's going to be covered in this class. So this only works if we're talking about a right triangle. So the Pythagorean theorem states that the sum of the squares of the leg lengths of a right triangle equals the square of the hypotenuse length. Okay, but what is a leg length? And what is a hypotenuse length? Those are some new words, right? So in a right triangle, the legs are the sides of the triangle that are adjacent to the right angle. And the hypotenuse is always the longest side, the one that is across from the right angle. So this is always the setup. The hypotenuse is always this side across from the right angle. The leg and leg we don't really care much about. They're just the two legs, right? Now, in other words, we could say that the sum of the squares would be leg squared plus leg squared should equal hypotenuse squared. Symbolically, if A and B represent the lengths of the legs and C represents the length of the hypotenuse, then we write this as A squared plus B squared equals C squared, which if you've ever taken a geometry class in the past, you've probably heard this one before. This is one of the best known triangle formulas, I think, is the Pythagorean theorem. Now, A squared plus B squared, notice that A and B, it doesn't matter which is which. A can be this one or it can be this one. It doesn't really matter because they're getting added up. So it's just we take the two legs and square them, and that should be equal to, this matters, it is equal to the hypotenuse squared. So the two legs have to be on one side of this equation, the hypotenuse on the other. Doesn't matter which information you know, the legs are on one side, the hypotenuse is on the other. That's very important. Now, what can we do with this formula? Well, we can solve a lot of application-based problems using it. So for example, the moat surrounding a castle is 18 feet wide, and the wall by the moat of the castle is 24 feet high, just like in this figure. If an invading army wishes to use a ladder to cross the moat and reach the top of the wall, how long must the ladder be? So in other words, we're trying to figure this out. Well, we know two sides, or two legs of this triangle that's being made here, right? That this is a right triangle, and we know two of its legs. So we could say A and B, and then we're trying to figure out C. Then we have our formula that we can plug directly into. 18 squared plus 24 squared should equal C squared. Well, 18 squared is 324, 24 squared is 576, which when added together is 900. So this is not C, this is C squared. So how do we figure out what C is? Well, you're going to either know the square root or you're going to press the square root key on your calculator, but you will get C is equal to plus or minus 30. But that's two answers, positive 30 or negative 30. But in this case, we're talking about a real world situation. Does negative 30 make sense for a number of feet? So remember, that's the unit we're working on here. No, of course it doesn't. So in this case, we just say the ladder needs to be 30 feet long because that's the only answer that makes sense for this problem. The last type of shape we're going to take a look at is now circles. So the reason we haven't talked about circles yet is because circles are not actually polygons. Remember that by definition, a polygon can't have curved sides. It's all straight lines with vertices, angles, connecting them and all of that. So a circle does not fall into this category because it is entirely one big curve. Specifically, the definition of a circle is a set of points that are equidistant, which just means equal distance, from a fixed point called the center. So in other words, here we have the center of our circle. Every point on the circle is exactly the same length from this center. That length is called the radius. We often denote the radius with the letter R. The radius is a line segment from the center of the circle to any point on the circle. Then the diameter, which we will refer to as D, of a circle is a line segment through the center of the circle with both endpoints on the circle. So a diameter is just 2 radii, which is the plural of radius. So 2 radii together makes the diameter because it's 2 of these line segments hitting, that's not how that works. There we go. Hitting either side of the circle, but it's one straight line. So the length of that radius is this equal distance that all these should have. Every one of these is the same length. These are all the exact same length, whatever R is. Now we can find the circumference of our circle, which is the length of the closed curve that forms the circle. Or in other words, it's basically the perimeter of the circle. We just don't call it a perimeter because circles are not polygons. But it means essentially the same thing where it's taking the length around the outside of our circle. And it is found by 2 pi r or pi d because d, the diameter, is just r plus r. So d equals 2r. So we can use either of these formulas. They're the same thing. Then the area is pi r squared. Once again, remember that our circumference, just like any other perimeter equation, only has one dimension to it, r, d, whereas the area has 2 dimensions, r times r. So it's still a 2-dimensional area. It's still going to be measured in feet squared or meters squared or whatever unit we choose, whereas the circumference is still a single unit, even though it now involves this new sort of number pi. So what is pi? Well, pi is defined by its relationship to the circumference of a circle. Pi is just the ratio between the diameter and the circumference of any given circle. But what is it for your purposes? For your purposes, it is a key on your calculator, or it is 3.14. Maybe you want a few more decimal places just to be safe. 3.1415926, whatever number you'd like. But 3.14 is usually the accepted amount for a class like this. But generally, just use the key on your calculator that for any scientific calculator or above, you're going to have a key that can calculate it for you. Please don't just say 3. We do not use just 3 for pi in this class. So that's what pi is. It's just a number. It's not a variable. It has a meaning. This is just a symbol to represent that specific number. So if we want to determine the area of the shaded region in this given figure, how would we do it? So we have a circle and a parallelogram in this picture. The circle has a 2-foot radius. The parallelogram has a 10-foot base length. We want the shaded region. So the shaded region is here and here, which essentially is taking this parallelogram and removing the circle from it. How do I remove the circle? In other words, I'm removing the area of the circle from the area of the parallelogram. So we get that the shaded region is the parallelogram area minus the circle area. But how do we find the parallelogram area? How do we find the circle area? Well, we know these formulas now. Parallelogram area is base times height, and circle area is pi times radius squared. So we need to identify what is the base, the height, and the radius. The base of this parallelogram is easy. That one's given to us. It's right here. That's our base. But the height is not directly given to us. The radius is, and the radius is actually going to help us find the height. The height, remember, is just the distance from the top to the bottom of this parallelogram. Well, distance from the top to the bottom of the parallelogram is the same there as it is here, as it is here. Oh, wait, but that's the diameter of the circle, right? I'm going straight through the center of the circle. So, in fact, the diameter is just 2 of the radius. So we can find the height by thinking about it as 2 radiuses. So our height is equal to 4 feet because it's 2 radii, which is the diameter, which is 2 times 2 is 4. So now we have all of our numbers we can fill in here. 10 times 4 minus pi times 2 squared. Now it does matter what order we do this in. We want to do 10 times 4 is 40, and then 2 squared is 4, before we multiply the 2 squared by the pi. Remember your order of operations. Remember PEMDAS, right? We do everything in the parentheses first, which is how we get the 40, and we'll work in these parentheses before we do this subtraction. Inside the parentheses, we do the exponent first, which is how we get pi times 4, not 2 pi squared. It's very different. Then we multiply those together and subtract. So here we get 40 minus 4 pi. Again, let your calculator figure out what 4 pi is. It's 4 times approximately 3.14, which is, going to be somewhere in the 12 to 13 range, since 4 times 3 is 12. So that can give you an idea. You want to always be estimating your answers to see whether or not they make sense to you. So in the end, we get 27.43. But what's our unit? Our unit is feet squared, because this is feet, feet, feet. They're getting multiplied together because this is an area. We're looking for an area, so the unit better be a square unit. Square feet in this case.